Welcome again. Let us look at rule 5, the fifth rule of indices. Here, I want us to have a look at division again. So let's consider a to the power 3 divided by a to the power 7. So you remember when we worked out this one, we have a to the power 3 over a to the power 7. So we have a times a times a divided by a times a. So we are multiplying a 7 times. 1 2 3 4 5 6 7. All right, so we are having a to the power 3, which is the numerator, and a to the power 7, the denominator. 1 2 3 4 5 6 7, just to confirm. So what we are going to get here, the 3 a's in the numerator can be divided out by 3 a's in the denominator. So this a divides this one, and this one divides this one, and this one divides this one. So in the numerator now we're left with 1 times 1 times 1, which is 1 over a times a times a. So we're left with 1 over a times a times a times a. So which is 1 over a to the, which is 1 to the power 1 over a to the power 4. 1 over a to the power 4. Can I write it much better? It's of a to the power 4. Okay, a to the power 4. Now, I want us to discuss what is the meaning of having 1 over a to the power 4. A to the power 4. Now, I want us to use the third or the other rule of subtracting indices. So we use the other rule of subtraction. We want to discuss what this one means. So initially we had a to the power 3 divided by a to the power 7. So the rules say that we're going to subtract the power of the denominator from the power of the numerator. So we have a to the power 3 minus 4, which is a to the power this one I made a mistake here, sorry. So minus 7, and then I'm going to get a to the power negative 4. Okay, so now I have this and I have that one. Oh, sorry. So I've got this. Let me use this a different color now. So here I've got this one, 1 over a to the power 4 when I calculate using this method. So I get 1 over a to the power 4. And if for the same problem, which is this one, or if I calculate the same problem, I can still get a 1. So I can get a, this one I can get a to the power negative 4. Then this tells us that what we started with, this one, 1 over a to the power 4 is the same as a to the power negative 4. Okay, so this is what we have here. So if we use the third rule, we get this a to the power negative 4, and if we divide just by expanding and then simplifying, we get this. So we're still calculating the same problem. So now we can safely say that a 1 over a to the power 4 is the same as a to the power 4. So a negative sign in the index can be thought of as meaning 1 over. So if we have a negative sign like this, so this is the same as 1 over. So now this then can make us conclude that so this is going to be our rule 5. So this, then we can conclude that if we have a to the power negative 1, so we said the negative index can be thought of as meaning 1 over. So it can be thought as meaning 1 over a to the power 1, or 1 over a. Okay, so, or let me simplify this one, or I can say a to the power negative m, to be more general, can be stored as 1 over a to the power m. Now you can see that initially we have the numerator, we have the power which is a negative power here. But if we put 1, like we've done here as a numerator, now we are not going to write the negative here, so m now is going to be positive. Okay, so let's make an example. So let's see if we can come up with examples. So we have, let's say, 2 to the power negative 2. What does that mean? So this one can be written, let's go back to the rule. The rule says if we have a to the power negative m, it's the same as 1 over a to the power m. So m is the power, a is the base. Alright, so here we have 2 as our power and a the base. So this one means we have 1 over 2 squared, so which is the same as 1 over 4. Okay, so let me use another example. So suppose we have 3 to the power negative 4. This is the same as saying 1 over 3 to the power 4. So if we have 3 to the power 4, that is to say 1 over 3 times 3 times 3 times 3. So if we have 1 over 3 times 3 times 3, we are going to get 81. So this is 1 over 81. So if they can ask you to evaluate this one, so you know that this one is 1 to the 1 over 81. So just one more example. So it's 5 to the power negative 1 can be written as 1 over 5 to the power 1. So you remember 5 to the power 1 is still 5. So it's 1 over 5. Okay. All right. Maybe one more example. If we have 1 over a can also be written as 1 over a to the power 1, which is a to the power negative 1. Okay, 1 over 7 squared can be written as 1 over, can be written as 7 to the power negative 2. So you see now what we did here, we just changed the here when we have 1 as a numerator, here, so we're going to write the denominator with no negative, so it's going to be positive. And then, but now if we remove the 1, so the numerator, the power is going to be, what did I say? If we have 1 as a numerator, the power is going to be a positive 1. Then now if we remove the 1, if we remove this one, so now the power is going to be negative, just like this one. Okay, so the key point here, which is the rule 5, so let me write it again. So the key point, which is our rule 5, just to, so that because it may be too far to go back, so it's 1 over a to the power negative m is equals to a to the power m. So it doesn't matter where you can come from this side to that side, or you can come from this side to this side, so it will still be the same. So let's do 2 more examples. So if I have, just to make sure that you get it, that's why I'm giving more examples, because most of the time learners, they do not like to deal with negative indices. 2 to the power negative 9 can be written as 1 over 2 to the power 9. Then you can simplify that one. So if we have 2 to the power 9, so that one is going to be 1 over 512. But then you can leave your answer like this one. So just to show that you understand the meaning of a negative index. Okay, but depending if they've said you need to leave it as proper fraction, so you need to go to this extent. All right, so maybe let's say 5 to the power negative 3. I want us to leave this one as a proper fraction. So what we will have here, we will have 1 over 5 to the power 3. All right, so this one is 1 over 5 to the power 3. It's 5 times 5 times 5. So if we have 5 to the power 3, we are going to get 125. Because 5 times this one is 5 times 5 times 5, and this is what we get, 125. So I hope the rule number 5 was very clear to you. So let me go back to the rule. So this is what the rule states. So this is the rule. We are saying 1 over a to the power negative m is equals to a to the power m, or we can come from this side. A to the power m is the same as 1 over a to the power negative m. All right, thank you very much.